I'm Rhett Jesse, and today we're going to talk about the Metrix 5580 signal conditioner and the SW5580 switch. To do this demonstration, we're going to use the SW5580 switch just so we can show the switch functions. But otherwise, the two units are identical. This demonstration is number 3 in a 5-part series. Today, what we're going to show are 2 velocity sensors going into one SW5580. We have a SV6300 in channel 1. That's going to go to channel 1 of the 5580, and we're going to see its response. And then we have a 5485C going into channel 2. And then we're going to see its response. And so we're going to see the vibration levels go up. We're going to see alarms come in, and we're going to see both latching and non-latching alarm functionality. And we're going to see how both these systems work. Now, what's unique about this demonstration is that the SV6300 is a piezoelectric device with an integrator built in. Whereas in channel 2, we have a moving coil device to give us our velocity. This is our 5485C high temperature velocity sensor. Okay, it gives an output of 200 millivolts per inch per second. So it's different from channel 1. So channel 1 was 100 millivolts per inch per second. This is 200 millivolts per inch per second. And it's a moving coil type. So channel 1 needs power, channel 2 produces its own power, its own EMF. So we're going to take advantage of that. But the SW5580 and the 5580 can both take either a powered device or one that doesn't need any power. And that's the key point. All right, in order to do this demonstration, I have a couple things connected to this besides the sensors. I've got power coming into it. I've got a reset that I can use to reset latching alarms. I've got 2 multimeters to the left, which are for showing you the milliamps on both channel 1 and channel 2. I have 2 ohm meters connected to the relays on channel 1. So we're going to be able to look at the alert and danger on those relays. To do this demonstration, first I need to show you what the set points are in the software. You can see in the software that channel 1 is for the SV6300, and you can see that by the 100 millivolts per inch per second. And then if you go to channel 2, you can see that's for the 5485C, and it has a scale factor of 200 millivolts per inch per second. Now both are set up for scale factors of 0 to 1 inch per second. Okay, and we can switch that to metric if we want to. So you can just go to metric units if you want to see things in metric. So there's not a problem with doing that. What I'd like to do now is go ahead and show you how this demonstration is going to work. And let's go ahead and go to relays. You can see in this relay screen that channel 1 is set up for an alert alarm at 0.25 inches per second, and the danger alarm is at 0.5 inches per second. Both have time delays of 3 seconds, and you can see that the alert has latching enabled. So we'll talk about that here in just a minute. On channel 2, we have the same settings. We have 0.25 inches per second for the alert and 0.5 inches per second for danger, both with a 3-second time delay. And you can see alert again is latching. Now in a latching alarm, what happens is when the alarm set point is exceeded, the vibration value goes down below. What will happen is the alarm will not reset. You'll actually have to press reset in order to get the alarm to reset. So that's what latching means. It's actually latched until you reset. Whereas the danger alarm is not latching, so when we exceed it and then we go back underneath that alarm set point, the danger alarm will clear. And remember, the alert alarm is a flashing yellow and the danger is a flashing red. All right, so what I'm going to do is I'm going to increase the vibration levels on channel 1 and then on channel 2, and we're going to see the alarms come in. First we'll see the alert, then we're going to see the danger. And then when we come back down, we should see the danger clear because it's non-latching, and we should see the alert not clear. And then we'll hit reset and we'll show that. And I'll do one channel at a time just so you can see it. So let's first start with channel 1. I'm going to increase its vibration level to 0.4. The alert should come in. We should see the relay change state, and then we'll go back. And we'll increase the level to see the danger come in. You'll see the relay change state, and then we'll do the same thing with channel 2. Let's go ahead and move forward. Okay, so I'm going to increase the vibration level on channel 1 to 0.4, which I did. And the relay came in. You can see the relay change state. It's at 0 ohms now, so we have a short circuit. The relay shut. Now what we're going to do is go up and go to 0.6. All right, and we have now a danger relay. You can see that we have a short again because the relay shut again. Now we're going to do the same thing on channel 2. We'll get both the alert and then the danger, and then we'll come off on channel 1, then channel 2. So I'm going to go ahead and increase the vibration level on channel 2 to 0.4. And at 0.4, we have the relay changing state. You can see it flashing yellow. And also you can see the milliamps are working properly. 0.4 is 40% of 16 milliamps, which is 6.4 milliamps plus 4 gives us 10.4. We're showing almost 11. That's within 5%, so that's really great results. All right, so let's continue to go up, and let's go to 0.6. We'll go past the alarm set point. It'll take a few seconds for it to kick in, 3 exact, like in our setup. And we can see that danger relay is in. All right, now I'm going to decrease the vibration level on channel 1. I'm going to bring that down to 0.4, and we should see the danger alarm clear and the relay open. And that's exactly what happened. The relay is now open. And now we're going to go ahead and decrease the vibration level again, and we should see the yellow LED. It should stay locked in even though I'm less than the set point of 0.25. We're going to go to 0.2. All right. So the LED is still flashing, and the relay is still closed. So you can see that short at 0, 0. Now I'm going to hit reset, and they both turn green because they have the 3-second time delay. Channel 2 is still in alarm, and you can see that, but you can see that we now have an open circuit on the alert channel, and you can see that it's green, and that's exactly what should happen. All right, so now we're going to go ahead and decrease the vibration level to 0.2 on channel 2, and we're going to see similar behavior. The danger will clear, and the alert will continue to flash until I hit reset. And then after the reset is hit, you'll see that everything is back to normal. We're at normal vibration levels, and everything looks good. And that's how it should work. And I can work that way on an accelerometer or a proximity sensor, and it will work very well for you. So that's the end of this demonstration. See you on the next one. Thank you.